Hi everyone, in this video we're going to be talking about mini proofs. Mini proofs means that when you're given a diagram, you then can make a conclusion based on that diagram and keywords. Let's take a look at the first example. Given M is the midpoint of AB. So notice in the diagram I have line segment AB and I have an M as the midpoint. I see the word midpoint and I circle that keyword. And I know that a midpoint creates two congruent parts. So therefore, I know that AM is going to be congruent to BM. And therefore, that's my conclusion. AM congruent to BM. And remember, this symbol, the equal sign with the squiggly line or tilde on top, means congruent. And congruent means exactly the same. So with these different types of questions, it's important to locate the keyword, circle it, write the definition, and then make your conclusion. Number 2, CD bisects AB at P. So the first thing I see is the word bisects. So I'm going to circle bisects, and that means we create two congruent parts. So CD bisects AB. So whatever comes second is being bisected. So CD is cutting through line segment AB to create two congruent parts. So AP is congruent to BP. And that's the conclusion. CD bisects AB at P. So therefore, AB is being cut into two congruent parts. AP is congruent to BP. Let's look at number 3. BE bisects angle ABC. So again, I see the word bisects. I'm going to circle the keyword, write the definition, two congruent parts. And in this case, I'm bisecting an angle. So again, BE here is cutting the big angle ABC into two congruent parts. So my conclusion is ABE, which is this angle, is congruent to CBE. Or what's even easier for us is to write in the numbers. So I can make this angle 1 and this angle 2. And I can just say angle 1 is congruent to angle 2. Make sure to label 1 and 2 in your diagram if you're going to write angle 1 is congruent to angle 2. Next, for number 4, AB and CD intersect at O. So there are no keywords in this question. We do see the word intersect, but that's not a vocabulary word. But that does notify that if those two lines are intersecting to form an X, I know here that I have vertical angles. And we know that they are congruent. So I'm going to write in numbers. I'm going to make this 1, this 2, this 3, and this 4. So therefore, angle 1 is congruent to angle 2. They're vertical angles. Vertical angles are across from each other and are congruent. And angle 3 is congruent to angle 4. So remember, anytime you see an X, those are vertical angles, and vertical angles are congruent. Next, for number 5, EF is perpendicular to AB at P. So for this, I'm going to circle the keyword perpendicular. And remember, perpendicular means they create 90-degree angles. So for example, here I have the box, which means 90 degrees. And I'm going to label all of the angles that are 90 degrees with 1, 2, 3, and 4. So angles 1, 2, 3, and 4 are right angles, or 90-degree angles. And because they're all 90-degree angles, they're all congruent to each other. So angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4. They're all 90-degree angles. So anytime you see the word perpendicular, think of 90-degree angles. But first you need to identify that they're 90 and then say that they're congruent. Next, for number 6, AB is perpendicular bisector of PQ and intersects at O. So here I see two words. I see perpendicular, which creates 90-degree angles, and I see bisector, which creates two congruent parts. So we can make two conclusions based on this diagram. So again, I'm going to label all the right angles as 1, 2, 3, and 4. So therefore, all the angles 1, 2, 3, and 4 are right angles, and angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4. But then I also have to take into consideration the word bisector. So I'm bisecting line segment PQ into two congruent parts. So PO is congruent to OQ. And notice I put in these congruent marks, and you should do as well. So again, here are my three conclusions. PO is congruent to QO, considering the bisector definition. Angle 1, angle 2, angle 3, and angle 4 are right angles, and therefore angle 1 is congruent to angle 2, which is congruent to angle 3, which is congruent to angle 4. Lastly, number 7, triangle ABC with AB congruent to AC. So if I see that AB is congruent to AC, I have two sides that are congruent. Therefore, the angles opposite of them are also congruent. And I'm going to write 1 and 2 in there to show that angle 1 is congruent to angle 2. If I have a triangle with two sides that are congruent and the base angles are congruent, I know it's an isosceles triangle. So my conclusions are, I can either write out the angles, angle ACB is congruent to angle ABC, or I can label them 1 and 2, which I think is easier, and triangle ABC is an isosceles triangle.